So in the last class, we already learned about a register that you need to familiar whenever you're going to use the ADC. So now we are going to use that register so that we can do programming as ADC programming. So there are two types of ADC programming. One is by using a polling method, the other one by using the interrupt method. So now we are going to see what are the steps that we are going to do in order to write ADC programming by using a polling method. So for the ADC, to write a program, okay, using ADC polling method, so there are few steps that you need to follow. Step number one, okay, you are going to initialize your ADC input. Okay, so you need to know where is your ADC input, which is for the Atmega 32, the ADC input is dedicated at port A. Okay, so this is your ADC input channel. Okay, then step number two, so you're going to enable, okay, you're going to enable your ADC, and then at the same time, you are going to select conversion speed. Okay, so this enable ADC and to select as conversion speed can be done, okay, inside ADC SRA register. Okay, so you can do this setting here to enable ADC and to select the conversion speed inside of this ADC SRA register. Okay, and then recall back. Okay, so this is your ADC. Okay, recall back that you have for the ADC SRA register. Okay, it is a 8-bit. Okay, so the bit that you need to focus here for in order to enable ADC and select the conversion speed is bit 7. Okay, so this is your ADC SRA. Okay, so you need to focus. Okay, so this bit here used to enable ADC, and then another bit here that you need to focus here is this last 3 bit here. Okay, so this is for conversion rate. So to enable the ADCs, so in this bit 7 here, you need to put 1 lah. Okay, kat sini you need to put 1, while for the conversion rate, it depending on your conversion. Okay, the speed that you're going to use. Okay, so there are a few prescale that you can use here for the conversion rate. Okay, if you use a 000, okay, if you're going to put a 000 at this conversion rate here, so this one is belong to reserve. And when you put a 001, so this is you're going to divide your extend your CPU speed by 2. And when 010, so this is for prescaler, 011, 8, and then you have 100 is for 16, 101 is for 32, 110, 64, and last but not least is 111 is for 128. Okay, so this conversion rate here, okay, you need to make sure lah. Okay, your speed, your processing speed is less than 200 kilohertz. Okay, that we learned in the previous class. So this is step number 2. While step number 3, okay, you're going to select your vref, and at the same time, okay, you're going to select your ADC input channel. Okay, so this can be done inside of marks register. Okay, and recall back your the mark register. Okay, so marks. This is marks. Also 8-bit white. Okay, to select the vref, you need to see at bit 7 and bit 6. Okay, so this is where you're going to select the vref. And then to choose your ADC input channel, you need to focus on this bit here. All right, bit 4, 3, 2, 1, and 0. Okay, so this is your marks. Okay, to select the ADC channel, and this is your vref. Okay, for this vref here, you have 3 vref. If you put 0, 0 means that your vref, you're going to select your vref coming from your aref. Okay, if you put 0, 1 means that the vref is coming from your VCC. And if you're going to put 1, 1 here dekat sini, so what happened here, the vref is coming from internal voltage, okay, which is 2.56 volt. Okay, that is step number 3. And then step number 4, okay, what you're going to do next is you're going to start ADC conversion. Okay, how to start the ADC conversion? By put 1 to your ADAC. Okay, so you need to set your ADAC equal to 1, so that after that the ADC conversion started. So where is your ADAC? Dekat mana you punya ADAC? Is it inside a ADMARC or ADC SRA? Where is the ADAC? Dalam which register? Can somebody tell me which register? Register mana satu? Okay, inside of ADCSRA, which is kat sini, bit number 6. So this is your ADAC. Okay, so this is step number 4. Okay, you need to make sure you need to start the conversion by put 1 to this ADAC. So macam mana nak tulis in C programming? Okay, so you can write down ADCSRA sama dengan ADCSRA, okay, or okay, whatever, because earlier you already did the setting for the ADCSRA, correct? So you need to take back this ADCSRA and then you do the logical or with this value. Okay, so put 1 to ADSC. Okay, so the value earlier that you have set here will not change. Only at this side here, or only at this bit here, bit number 6 change. Okay, when you do step number 4. So this is the programming that you're going to do. Okay, then lepas tu step number 5. Okay, what is step number 5? Okay, you're going to monitor. Okay, you need to monitor your ADC flags. Okay, what is your ADC flag called? Okay, we call it as a ADIF. Okay, kat mana this? Where is this ADIF location? Dekat mana kita nak, where you going to monitor this ADIF? In which register? Is it ADMARC or ADC SRA? Anyone? Okay, your ADIF also inside of your ADC SRA. Okay, so you need, so how to monitor? So to monitor this ADIF, okay, so you need to use a while loop lah, same as we did in the timer programming, okay, which is we're going to monitor using the while loop. Okay, so since this ADIF is inside ADCSRA, okay, so you put while ADCSRA and with okay, ADIF is it equal to 0? If yes, and it will keep monitoring the ADIF. Okay, once the conversion stop, the conversion finish, so what happen here, the ADIF will go high. So whenever the ADIF go high, so the CPU will exit from this loop. Okay, then step number 6. Okay, so step number 6, what you're going to do is you're going to read the conversion value. So the conversion value will be stored dekat mana? Okay, all the conversion value will be stored at ADCL and ADCH. Okay, so this is the step that you're going to do in order to program ADC by using polling method. Okay, so let's look at some examples here. Okay, so this is the connection lah. Okay, so this connection here, you have a sensors. Okay, so this sensors here, you connect to ADC channel 0. Sorry. Oh, sorry. That one is for sensor interfacing. Okay, silap ya. Not that one. All right, so this one. Okay, so this is the ADC connection for program 30. For the next examples, okay, you can see here. Okay, you have a sensors. Okay, so this sensors here is connected to channel 0, and then this is the standard, what we call here, standard circuit lah. Okay, in order to use the ADC, so make sure that your vref, GND, and VCC are connected to capacitor and inductor. So this is the standard circuit in order to use the ADC. And then you see here another you have a LEDs. Okay, this LEDs here is connected to port B and port D, which is every time you the CPU read the value from this sensor, and after that, after the ADC is to display the analog value from this sensor here, so it will display to this LEDs. So now you're going to do the program based on this connection here. So macam mana nak buat? Alright, so this is the one that we will done if you're going to use the assembly language lah. But for this course, okay, for the ADC programming, we are going to use the C program. Okay, so now we are going to write down, okay, this example here. Okay, so I just copy this one here. Okay. Okay, so this is for the assembly language. Okay, now we are going to write down in assembly language. Oh, sorry, in C programming. Okay, so you see here you have a LEDs connected to port D and port B, and then you have the ADC sensors connected to your ADC 0. So we are going to use a poly method to read this sensors value here and display the output to this LED. So how to do that? Okay, macam mana nak buat? Okay, first, macam biasalah. Okay, so what you're going to do is you need to include the header. Okay, so include avr/io.page. Okay, and then for the ADC, we doesn't have any special library that we're going to include. Okay, so only need to include this one. Okay, io.page. Okay, and then you start with your main program lah. int main void. Okay, so open curly bracket and close curly bracket down here. Okay, so first, what you're going to do? Okay, first is we're going to initialize our ADC input. Okay, so since our ADC input is located at port A, so we need to make sure that the port A become our output port. Okay, so how to do that? Okay, by use the DDR lah. Okay, DDRA equal to what number here? What value that we're going to put kat sini? Okay, so to make port A as an input port. Anyone? What value that you're going to put to your DDR? A. Okay, so 0. So DDRA equal to 0. So what happened here? Port A, you initialize it as an input port. Okay, so this is step number 1. Okay, of course lah, you're going to initialize another port here. Okay, because so instead of initialize the port A as an input port, then you need to initialize port B and port D as a output. Why? Because you're going to connect it to LED. So DDRB sama dengan 0xFF and DDRD sama dengan 4xFF. Okay, so this is step number 1. Okay, you're going to initialize an ADC input channel as well as any other ports. Okay, and then step number 2. Okay, so what is step number 2? You're going to enable ADC and select the conversion speed. Okay, so contohlah in this example here. Alright, so I just assume that. Okay, contohlah this example here it says that so the clock the prescaler that you're going to use is 1 to 8. Okay, and then what else? Okay, the vref reference is coming from internal voltage reference, okay, which is 2.56 volt. Okay, and then I think this all add, and then your addla. Okay, so this one is write justified. Okay, you're going to read the what we call it the value as a write justified. Yes. So this step number 2, you're going to enable ADC, select the conversion speed. So how to enable ADC? So by do a setting inside of your ADC SRA lah. So ADC SRA. So what value that you're going to put here? So I just write down in binary number 0 bit. So to enable ADC, so we're going to put 1. Okay, dekat sini. Okay, we're going to put 1 to bit number 1. Bit number 7. Okay, to enable ADC. What about the rest? Okay, the rest you put 0, 0, 0, 0. And what about the conversion speed? Okay, the conversion rate. Okay, since now we are going to use a 1 to 8 prescaler, So we're going to put 1, 1, 1. Okay, so 1, 1, 1. So this is the value. Okay, which is, you know that. Okay, so you're going to enable ADC and with a prescale ataupun conversion speed of 1 to 8. Okay, then step number 3. What is the step number 3? Step number 3, you're going to select your vref and ADC input channel. So this can be done, okay, inside of add marks. So you just write down add marks equal to 0b. Okay, since, okay, for the vref, okay, you're going to use this 2.56 volt. Okay, so this is an internal voltage reference. So the setting here is 1, 1. So 0b 1, 1. And then this is your ADLA. Okay, this is your ADLA. Either you're going, if you put 0, so this one is right justified. If you put 1, this is a left justified. Okay, so now we are going to use a right justified. So we just put 0 there. And then what about the marks? Okay, what are the value of these marks here? Can somebody tell me? Okay, so now you're going to use the ADC0, which is this is a single, okay, single ended channel. Okay, ADC0. So what is the value that you're going to put to your marks here? Siapa nak tolong? Anyone? Okay, 0, 0, 0, 0. Okay, so this is the table that you're going to refer to. Okay, ADC0. Okay, single ended input. Sorry. Okay, ADC0. So the value that you're going to put here is 0, 0, 0, 0, 0. Okay, so I just put 0, 0, 0, 0, 0. So you know that this is a vref 2.56 volt and then with ADC zeros. Okay, single ended input channel. Okay, then step number 4. What is step number 4? Okay, you're going to start the conversion. Okay, so to start the conversion, you need to set 1 lah to your ADC. So this ADC is like of your ADC SRA. So how to do that? So ADC SRA sama dengan ADC SRA, which is this value here. Okay, we copy back this value, okay, to this here, and then all-kan dengan, okay, you can put 0B, and then what is the location of ADAC? Dekat bit 6. Okay, so you can put 0, 1, 0, 0, 0, 0, 0, 0. Or you can put, okay, or you can tulis ataupun ADSCRA sama dengan ADSCRA or with, okay, shift 1 to ADSC. Okay, this one is equivalent lah. Okay, then step number 5. What is step number 5? Okay, step number 5, you're going to monitor this, what we call here, the ADIF flags. So how to monitor ADIF flags? Okay, by write this program here. Okay, Y ADCSRA and with ADIF is it equal to 0? If yes, then it will keep monitoring. If not, it will exit from this while loop. Okay, and then after that, once you dah conversion is finished, then you're going to read the ADCL and ADCH. Okay, let's lah. Okay, this port D here, okay, because you have a port B and port D to display the value, okay, the conversion value. Okay, let's port B become your higher byte and port D to display your lower byte. So what you're going to do next is, okay, port D sama dengan, okay, your ADCL, because this is for the lower byte. So ADCL, and then port B sama dengan ADCH. Okay, so this is step number 6. Okay, so this one here, you just read the ADC, you just do the ADC conversion one time only lah. Okay, if you're going to continuous read the ADC value, how to do that? Okay, from this program here, if you see, okay, so first you enable this input and then you do the enable this ADC and then set the add marks here and then start the conversion and then monitor the flags and send the value to port D and port B. Okay, the ADCL and ADCH value to port D and port B. So this is only happen one time, once. Okay, so what happens if you're going to read this value from this sensor continuously? So how are you going to do that? Anyone? Macam mana nak buat? Kalau kamu nak read ADC, you going to change, you going to convert this. Okay, you're going to read the sensor and display the output continuously. So we're going to use the while loop. Okay, kita kena pakai while loop lah. So this while loop here, you just put dekat sini, in between here. Okay, so while 1. Okay, so open clear bracket and close clear bracket. Okay, so make sure that the while loop is in between 4 and 5. Okay, so you put while loop here. Okay, so it will keep continuous. Okay, convert the ADC. Okay, so this is by using the polling method. Okay, so now we are going to see how to write a program by using the interrupt method. Okay, so this is the step that you're going to do in order to write a program for ADC by using the interrupt. So I just write down here. Okay. Step number 1. Okay, so step number 1, that what you're going to do is, okay, you're going to include interrupt header. Okay, so every time you're going to use interrupt, so make sure that you include this interrupt header, which is hashtag include avr/interrupt. Okay, so this is step number 1. Okay, step number 2 sama juga lah dengan yang atas tadi, which is, okay, you're going to enable ADC input. Okay, so step number 2 for ADC interrupt is to initialize the ADC input. Okay, initialize ADC input. And then number 3, step number 3, enable ADC, and then since we are going to use the interrupt, so we're going to enable the interrupt, okay, inside our ADC, which is we call it as a ADIE. Okay, and then last is you're going to select conversion speed. Okay, so this will be done inside of this ADC SRA lah. Okay, so the AD here, okay, is located dekat bit 4. Okay, inside your ADC SRA. So this is your AD. Okay, every time you're going to use the interrupt, so make sure that this ADI is enabled. Okay, and then step number 4, okay, sama dengan atas lah, in which you're going to select vref and ADC input channel. Okay, so this one will be done inside the add mark. Okay, and then step number 5, okay, you're going to enable global interrupt. Okay, you need to enable SEI. Okay, similar to what we done in the interrupt programming lah. Okay, you need to enable you have 2 locations that you're going to enable the interrupt. One is inside of this ADC SRA, and then satu lagi dekat SEI, which is inside of your status register. Okay, step number 6. Then you start your conversion. Okay, and step number 7. Okay, you're going to create the ADC ISR. Okay, create ADC ISR. Okay, interrupt service routine for ADC, and read ADCL and ADCH value. Okay, so make sure lah. Okay, the name is correct lah. Okay, which is ISR, and okay, and then followed by ADC underscore. Okay, so this is for the interrupt service routine for ADC. And then dekat sini, if you're going to read again, okay, if you're going to convert again the to convert the analog to digital converter again, okay, if you're going to use the ADC again, so what you're going to do is you need to start another conversion inside of this ISR. Okay, so this is the step that you're going to do. Okay, you have 7 steps here. Okay, compared to polling you only have 6 steps. Yes. So this is the one that I told you. Okay. Okay, this is your ADI location. Okay, which is you're going to enable this ADIE. Okay, this ADIE stands for ADC interrupt enable. Okay, and then this is a vector table. Okay, if you're going to do the interrupt, okay. Okay, so you see here. Okay, this is the ADC conversion complete. Okay, we're going to do this one here. Okay, for the C programming, the ISR name will be ISR ADC underscore vet. Okay, so this is the same program, okay, that we did earlier. Okay, similar to this one. Okay, but this one is this is by using a polling method, and this one is by using the interrupt method. Okay, so now we're going to write down using the C programming lah, because this is an assembly language. Okay, so now we're going to write in programming, C programming. Okay, so so let's start with the same examples here. Okay, the same as above example here. So now we're going to write it by using the interrupt ADC interrupt method. Okay, so first, what are you going to do? Okay, so include all the file. avr/io.h, and then step number 1 here, you're going to include the interrupt header. Okay, so include another file, which is interrupt header. Okay, so this is step number 1. Okay, and then you start with your main program lah. Okay, int main void, and then open curly bracket and close curly bracket down here. Okay, so next, okay, you're going to initialize the ADC input. Okay, since ADC input is located at port A, so DDRA sama dengan kosong, and then at the same time, okay, you're going to send the output, okay, the value of ADC to port A and port D and port D. Okay, so you need to initialize the port D and port B as an output port. So DDRB sama dengan OXFF. DDRD also sama dengan OXFF. Okay, next step number 3. Okay, step number 3, you're going to enable ADC. Okay, so this is step number 2. Step number 3, enable ADC, enable ADIE, and select conversion speed. Okay, so this will be done inside of your ADC SRA. So ADC SRA sama dengan 0B. So what value that you're going to put here? Okay, so this is your ADC SRA. Okay, so this one to enable, you need to put 1 here. ADIE also, you need to put 1. And then the conversion speed, okay, the prescale that we're going to use is 1 to 8. So this one is 1, 1, 1. So the value is 0B1000, and then followed by 1, 1, 1, 1. Okay, enable ADC, ADIE, and prescale 1 to 8. Okay, step number 4. What is step number 4? Okay, select vref and ADC input channel. So this will be done inside of your add marks. So add marks sama dengan what value that you're going to put here. Okay, since the what we call here. Okay, you're going to use the internal vref. So the value is 1, 1. And then at last, right justified, we just put 0 here for the right justified. And what about the marks? Since the sensor is connected to ADC0, single-ended, so we're going to put 0, 0, 0, 0. Okay, so this is step number 4. Okay, next, step number 5. Select your SEI. Okay, so select SEI. Sorry, enable SEI. So how to enable SEI? Okay, write down this syntax here. And then after that, step number 6. Okay, this step number 5. Step number 6, you're going to start the conversion. Okay, so how to start the conversion? Sama macam yang previously lah. Okay, which is ADCSRA sama dengan ADCSRA you all with, okay, shift 1 to location of ADSC. Okay, so this is when you start your conversion. And then After that, what are you going to do? Okay, we're going to use the while loop lah, because we're going to do it continuously. Okay, so while loop, while once, so open curly bracket, close curly bracket. So inside of while loop, there is nothing to do here because we are going to check either the ADC interrupt is triggered or not. Okay, so we just put nothing lah kat dalam your while loop. Okay, and then after that, we are going to create the ADC ISR. Okay, so this is step number 7. Okay, to create ADC ISR. So step number 7. Okay, ISR, make sure that the name is correct lah. ISR ADC underscore. Okay, and then open curly bracket and close curly bracket down here. Okay, so now you're going to read the ADCS L and ADCH and put it, okay, display it to your port B and port D. Okay, let's your port D is for the lower byte and B is for the high byte. Okay, just write down. Port D sama dengan ADCF while port B sama dengan ADCH. Okay, then you're going to start the conversion again. Okay, so that you can do it continuously. So how to start the conversion? By write this syntax, this program here, which is ADCSRA sama dengan ADCSRA. Okay, and then all with 1. Okay, so this is how you're going to write the ADC programming by using interrupt method. Okay, any question? Ada soalan tak? Okay, so in this case here, okay, the interrupt only be triggered whenever the what we call here, the ADIF equal to 1. Okay, whenever the conversion is what we call it, the conversion is finished, and then the ADIF equal to 1, then it will trigger to ISR. Okay. It is similar to the timer interrupt programming lah. Okay, because timer interrupt programming, we are going to monitor the either your TOV ataupun OCF flags. Okay, but this one here, the CPU will monitor this ADIF flag. If the ADI flags equal to 1, so what happen here, the CPU know that the ADC is triggered and it will go to this ISR. Okay, ADC ISR, and then it will display this value here. Okay, the hasil conversion to this port D and port B. Josh asking, okay, do we need to reset ADIF in ISR? No need, because that one will be done by, okay, that one will be automatically done by CPU. Okay, because this is interrupt. Interrupt whenever the what we call it, the flag here. Okay, the flag that we use for the interrupt will be automatically, okay, reset by CPU. Okay, no need to do it manually. Okay, and then could you Zuan asking that why we need to start conversion again in ISR? Okay, if you not start the conversion, this conversion again inside of ISR, what happen is the interrupt only trigger one time. Okay, because we're going to do it continuously, so we need to start the conversion again. Okay, previously in the what we call here in polling, okay, in order to to continue, okay, to continuous do the ADC conversion, we need to use a while loop kat sini. But for interrupt, in order to continuously, okay, doing the what we call here ADC conversion, you're going to start the conversion inside of this ISR. If not, it will done once, okay, one time. Okay, if no question, then we look at another examples here. Okay, so refer to the flow chart. Okay, in this figure here. Okay, the program is running on a 4 megahertz clock. Okay, give you the estate is 4 megahertz. Okay, and up mega 32 that reads continuously. Okay, see that the word continuously, so it will do continuously. Okay, so ADC will be converting continuously. Okay, a single ended input from ADC 0. Okay, again we use the ADC 0, which is set with an ADC frequency of 62.5 kilohertz and full scale voltage of 2.56 volt. Okay, so how to do that? And now we're going to write the program. Okay, based on this, what we call here, based on this flow chart here. Okay, so now, okay, given that the external is 4 megahertz, and then dia bagi tahu kat situ ADC frekuensi sama dengan 62.5 kilohertz, and then the vref is 2.56 volt, and so now you're going ADC channel that you're going to use is ADC. Okay, so write the program. Okay, so according to this program here, so this program will be done by using the polling method. Okay, so first, what you're going to do, okay, in order to read ADC, first you're going to initialize this port B and port D, and then initialize port A as an input port. Okay, sama lah. Okay, since this is a polling method, okay, we have 6 steps here. Previously, we already learned. Okay, step number. Okay, so this one we need to include avr/io.h. Okay, and then after that, you started with your main program lah. Okay, so first initialize port B and port D as output. Okay, sama juga. Okay, DDRB sama dengan OXFF and DDRD sama dengan OXFF. Okay, so this one here will display your conversion. Okay, your digital output. Okay, and then initialize the port A as an input because this is an ADC. So we need to make sure that our port A become as a input port. Okay, how to do that? By putting DDRA sama dengan kosong. Okay, kat sini, if you're going to define the external pun boleh juga. Okay, so just define. Okay, sorry. F underscore CPU ya, to define. Okay, F underscore CPU. Okay, for okay. Okay, so this is how we're going to define the external here. Okay, next. Enable ADC and set prescale of 64. Okay, macam mana kamu tahu the prescale is 64? Okay, because you know that the ester is 4 MHz. Okay, usually, okay, ADC frekuensi F ADC sama dengan F bahagi dengan prescale. Okay, since you already have the ADC frequency here, which is 62.5 kilohertz, and the external speed is 4 megahertz, and now you're going to find out what are your prescale. Okay, so prescale sama dengan 4 megahertz divided by 62.5 kilohertz, then you will get, okay, press the calculator berapa ya? 4 megahertz bahagi dengan 62.5 kilohertz, you will get, okay, 64. Okay, so you will get this 64 here. Okay, so this is step number 1, which is you need to initialize your ADC. Step number 2, okay, what is step number 2? Okay, step number 2, you're going to enable, okay, enable your interrupt and as well as the conversion speed. Okay, so ADCSRA sama dengan 0B. Okay, to enable interrupt, you need to put 1 lah kat sini. 0, 0, 0, 0. What about the prescale kat sini? The value for the conversion speed. Okay, for the 64, the value is 110. Okay, so this is for the 64. Okay, so you're going to put 110. Okay, that is step number 2. And step number 3, okay, before you're going to start the conversion, you need to make sure lah. Okay, you're going to select the vref and ADC input channel. Okay, so this one will be done inside of your add marks. So add marks sama dengan 0B. Okay, what is your vref? Vref is 2.56 volt. Okay, sama juga dengan yang ni. You put 11 dekat situ. Okay, and then add lah. Okay, by default we use a right justified lah. Okay, you just put 0 for add lah. And what about your marks? Okay, what about this mark here? Okay, since we are going to use the ADC 0, so value dia sama lah dengan previously. Okay, so 0, 0, 0, 0, 0. Okay, and then step number 4, start ADC conversion. So start of ADC conversion. Okay, since this one here, okay, you're going to do it continuously. Okay, previously we know that to do it continuously, we need to make a while loop. Okay, so we start with while loop. While 1, open curly bracket, and barulah step number 4, start your ADC conversion. Okay, so ADCSRA sama dengan ADCSRA, okay, all with ADSC. And then step number 5, monitor your ADIF flags. So how to monitor ADIF flag? By using the while loop. Okay, so ADCSRA end kan dengan okay, is it sama dengan kosong. If yes, it will keep monitor. If not, it will exit the while loop. Okay, and then step number 6. Okay, so what you're going to do? Okay, you're going to read the ADCL and ADCH. Okay, how to read the ADCH and ADCL? Okay, by put it to your output port ni lah. Okay, so hantar pada kamu punya output port. Okay, this one here is for the high and this is for low byte. Okay, so ADCL, sorry. Okay, port D sama dengan ADCL and port B sama dengan ADCH. Okay, and this is for the polling method. Okay, what about if the question here, okay, instead of, okay, written from the subroutine, okay, written, okay, we change this question here, written from the ISR. So how to do that? Macam mana nak buat? So if you, okay, if you see the word ISR means that you're going to use the interrupt method. Okay, so saya just write down in. Okay, I just use the same program lah. Mana tadi? Okay, so what you're going to do is from the same program, okay, you just, okay, first you need to include the interrupt file or interrupt header. Okay, so this is your main program, and then this one is similar. And what about here? Okay, so this one here, you're going to enable your ADIE. So macam mana nak enable your ADIE dekat bit number 4. So sekarang you gantikan this one with 1. Okay, see here. Okay, so this is your ADIE, which is at bit number 4. Bit number 3. Bit number 3. Okay, so you put 1. Okay, the red color here is the changes lah, the modified that you're going to do in order to write ADC programming by using interrupt method. Okay, and then this one is same lah, add mark. Okay, and then while loop here. Okay, and then is, okay, so dekat sini, so instead of you put the ADC SRA dekat inside of your while loop, now you're going to put here dekat sini. So ADC SRA sama dengan ADC SRA. Okay, then after that you do the while loop. Okay, so inside of while loop, nothing lah. Okay, do nothing. Okay, just monitor the ADI flags. Okay, so once you finish monitor the ADI flag, and whenever the ADI flag goes high, so you're going to do the interrupt service routine. Okay, so you just write down the interrupt service routine down here. ISR sama dengan ADC underscore vet. Okay, open curly bracket. So what you're going to do is you need to hantar the value to your port D and port B. ADCH. And after that, you need to start the conversion again. Okay, and then close the ISR. Okay, itu saja. Okay, any question for the ADC programming? Okay, if no question, then I think we stop here. Okay, meanwhile, for the remaining of this slide here, okay, for the DSC, okay, how to calculate input output is the I out here, okay, and sensor interfacing I will what we call here, I will explain it in another video. I will give you the video. Okay.